So the real power of radian measure actually can be seen right out of the get-go by taking a look at what's referred to as arc length. Now, what is an arc length? Well, it's just literally a length of an arc, the arc of a circle. So let's suppose I have a circle, and let's suppose it has radius r. And suppose I take a look at a little wedge, so I make an angle. Say I go out to here, and that angle, I'm going to call that angle theta. By the way, a lot of times we use the Greek letter theta to represent the measure of an angle. So that's just the Greek letter theta, lowercase. Now, you'll notice that if this thing has radius r and I sweep out theta as the angle, there's an arc here. And sometimes it's actually useful to know how long that arc is. Not the circumference of the entire thing, but just the length of that little piece right there. So what is the arc length of this arc? Well, it turns out, since we're using radians as the measure of angle, and we know that sort of once around is actually a complete cycle, so that would be 2 pi, you can actually then find the arc length of any arc for any circle by the following formula. So the arc length, which is sometimes referred to as S for arc length, don't ask me, is actually equal to the radius measured in radians the radius measured in whatever, multiplied by theta, the angle measured in radians. So this is in radians. In radians. This will not work if you're using degrees. So it's a very simple formula. For example, let's just check this, see if it makes sense. What if I go make one complete cycle around? One complete cycle around, okay? Then the arc I'd be spanning would be the entire arc of the circle. So what's the arc length of that? Well, this formula says it's going to be r times that angle in radians. Well, once around is 2 pi, so that would be r times 2 pi, or 2 pi r. But wait a minute. Once around is just the circumference, and that's 2 pi r. So you can see this checks with what we know, that once around, that circumference is 2 pi r. And that's what this formula says, r times 2 pi. And so therefore, halfway around would be what? It would just be pi r, because this angle would be pi, and I multiply it by r. So in fact, when you measure things in radians, you can immediately start to get lengths of arcs and so forth. As a little teeny application, let's just take a look at the following. Suppose that we have a surveyor. So a surveyor is someone that sort of, looks into one of these things and looks out, spies into it, and then sort of wants to measure how far away things are. And let's suppose that we have a surveyor and an assistant. Here's the assistant. Looks like maybe a sumo wrestler, but really it's just the surveyor assistant way over here. And the surveyor measures. By the way, suppose that we know that the assistant is 6 feet 1 inch. Okay? So this surveyor is 6 feet 1 inch. And the surveyor sort of has that thing that measures angles. Let me just smooth this out here for a second. There's the surveyor. And this angle right here, it's very, very tiny. It's only a half of a degree. Half of a degree. And the question is, how far away is the surveyor from the assistant? So what is this distance right here? Well, how could we answer this question? Well, let's see. What we could do is say, well, this is such a tiny degree. I mean, a half a degree is like almost nothing. It's just like this little thing here. It's like, I feel like I'm doing origami. See the bird? But it's so tiny that, in fact, this distance here isn't going to differ too much by the circle that would sort of go through that point. That arc of the circle. So let's find the length of the arc of the circle. And let's assume, in fact, let's not find it, but let's assume that it's roughly 6 feet 1 inch. The same as the guy, right? Because if it's so tiny, there's very little difference between that little arc of the circle length and the actual straight person length. So if we do that, we can go into this formula, and we know the angle. We know this arc length, 6 feet 1 inch, and we can then solve for the radius. And that would tell us how far these two people are. Now, what do I do with the 1/2 degrees? Do I put that in here? Absolutely not. I have to convert that first to radians. So how do I convert that to radians? Well, here's what I always do. I just start from ground zero and say, okay, well, 360 equals 2 pi radians. So I want, so that means that 1 degree equals pi over 180 radians. But I want 1/2 degree, so I multiply everything through by 1/2, and I see that 1/2 degree would equal pi over 360 radians. Aha! So the angle is really pi over 360 in radians. So we put in pi over 360 here. And what do we put in here? Here we put in 6 feet 1 inch, which let's just convert everything to inches. That would be 73 inches. So I see 73 inches equals the radius, which is not known to us at the moment. And then the angle is pi over 360. So that means that the radius would equal 360 times 73 all over pi. And what does that work out to be? Well, if you work that out on a calculator, you see that equals, let's see, 8,365.18 inches. Okay, that's inches, but how many feet is that? Well, if you just divide that by 12, you would see it equals 697.09 feet. So just knowing the angle and how tall our sumo wrestler assistant was, we could actually figure out how far they are apart. Now, of course, I'm using the fact here that this angle is very, very tiny. So there's very little difference between the assistant's height and this arc length. But suppose that, in fact, the angle was bigger, so it was very dramatic. Well, then, in fact, the straight line distance would be a lot different than the arc distance. The arc distance would probably be greater. So it raises the question, how could I find sort of information like this if I just know straight line distance, and I don't want to estimate it using this arc thing, but I want to somehow do it some other way? Well, it turns out that's where the trigonometric functions and the power of trig will come in, because that's how we're going to finally figure out how to do that kind of thing exactly. But for now, I hope that this arc length formula gives you a sense of, first of all, how to find the length of an arc if the angle is measured in radians, and also the power of radian measure, the measure of choice by mathematicians and by us together.